So adding and subtracting radical expressions is a little bit tricky. So you need to be aware that you can only add and subtract radicals if they have the same index and the same radicand. Okay. So to add and subtract, what we do is we actually add and subtract the numbers in front. You can think of them like coefficients. And then we keep the radicals the same. So we're going to think of that radical part as a variable, and then you're just collecting like terms. Okay. So if we have 9 times the square root of 5 plus 2 times the square root of 5. So look at your radical parts. I have right there, both have indexes of 2, which we can't see. The radicands are both 5. But I have 2 terms that have the square root of 5 in them, so I can absolutely add those. The square roots of 5 stay the same, and what I do is I just add those numbers in front. So 9 square roots of 5 plus 2 square roots of 5 is 11 times the square root of 5. Okay. Now, here's another example. 8 times the square root of x minus the cubed root of x minus the square root of x plus 7 times the cubed root of x. So when I look at that first term, 8 times the square root of x, it can only combine with another square root of x. So I'm going to look through, right? Not that one, but this one. Here's another square root of x, and then not that one. That's a cubed root. So these two terms here can combine. So I have 8 square roots of x, and then I subtract. This is 1, right? Subtract 1 square root of x. So I have 7 times the square root of x. I've done those two. And now I have negative cubed root of x. This can combine with the other cubed root of x term right here. So I have negative 1 plus 7, right? We're just doing the coefficients. So that's plus 6 cubed root of x. Notice the radical part stays exactly the same, right? We're just collecting those. Again, it's just like collecting like terms. Okay, do you want to pause and try this one? So 6 square roots of 10, the only thing it can add or subtract with is another square root of 10 right there. So 6 minus 1 is 5 of those. So 5 square roots of 10. And then 3 square root of 6, this can combine with other square root of 6 right there. So 3 of them plus 5 more. It's those numbers in front that we add. So 8 times the square root of 6. Okay, so now if the radicands are not the same and you're in a math class, right, sometimes what you can do is you can do a little manipulating on the radicand to make them the same. And we're going to be looking for some clues just to help us along. So for instance, 7 times the square root of 2 plus the square root of 50. Well, right, they have the same index. They're both square roots. That's good. But this one's a 2 and that one's a 50. They can't add like they are. However, right, if we simplify that second one, then I think we'll get something that we'll add. So we're going to go ahead and simplify the square root of 50. Right, so remember we look for perfect square factors, and we're going to keep an eye on, right, what we need. Right, so it would be super helpful if somehow I had a square root of 2 left over so I could add it with that first term. So if 2 is one of the factors, its partner would have to be square root of 25, which is great because that's a nice perfect square. So square root of 50 is 5 square roots of 2. So here we go. So we have 7 square root of 2 plus 5 square roots of 2. Now they are the same, and we can add them to get 12 square root of 2. Okay, how about this one? Now I have cube roots, and I have a cube root of 5 and a cube root of 40. Not the same, right? But okay, let's see. Can I simplify the cube root of 40 in such a way that I get left with a cube root of 5? So I'm kind of just doing a little workspace over here just to see if it's going to work out for me. So if 5 is one factor, its partner would have to be 8 to get back to 40. 8 is a perfect cube. That's awesome. So 2 times the cube root of 5. So now I have 14 times the cube root of 5 minus 2 times the cube root of 5. So now they are the same. So we go ahead and subtract those coefficients. 12 times the cube root of 5. Okay, so let's put everything together. So we're going to perform the operations and simplify. Feel free to pause and try these on your own and then meet me at the end. So this first one, I have a square root of 6 and it's multiplying a binomial. So, right, when that happens, we have to distribute. So I'm multiplying two radicals, same index. So multiplying, right, the only thing that has to be the same is the index. So now I have the square root of 12. And then my next one, what do I get there? Minus, so the 7's out in front. I don't have anything out in front of my square root 6, so that'll just be the 7 by itself there. And then underneath, I'm going to get 6 times 3 square root 18. Okay, well, that's good. Let's take a quick look here. 12 and 18, those aren't the same, but they do both simplify. So maybe if we simplify them, I'll get something that will. So reduce your square root of 12. Let's see, what is that? 2 times the square root of 3. After you've done enough of these, you'll start to see those. It's okay if it takes you some steps. Go ahead and write. You break it apart into the perfect square factor, kind of like we did up here with the 50 and the 40. Okay. So square root of 18, I'll show you that one because I don't think I've done that one for you yet. So square root of 18, perfect square factor. What goes into 18 that's a perfect square? That would be 9. 2 left over. Square root of 9 is 3. Can you stay with me? So now this square root of 18 is going to be 3 times the square root of 2, but the 3 is going to multiply that 7 that's out front. So I'm going to have minus 21 times the square root of 2. Okay, the 3 and the 2, those aren't going to simplify any farther, and they're not the same. So there is nothing else I can do with that one. Let's see, x minus square root 7, quantity squared. Be careful. I have a subtraction here, right? This means I want x minus square root 7 times itself. And if we were multiplying two binomials, right, the way we do that is we distribute every term in the first through the second, or FOIL if you prefer. So x times x is x squared minus x times the square root of 7. You can put the x at the end if you want. Minus x times the square root of 7. I don't typically, just because sometimes it tries to sneak under the radical, but it's not wrong. You're just not going to see me do it very often. Okay, let's see. I did first, outer, inner, last. So negative square root 7 times negative square root 7 plus 7. Let's see. Oh, I can add these two together. Okay, that's kind of obnoxious. Stay with me. X squared minus 1x square root 7 minus another x square root 7. The way we write that is minus 2x square root 7. Okay, and then plus 7. Okay, how about this one? X plus 13 times x minus 13. So we're going to do the FOIL again. X times x is x squared. X times negative root 13, so minus x square root 13. And then positive square root 13 times x. So that's going to be the positive version of that same term. And then finally, square root 13 times negative square root 13 is just a minus 13. So this time, those two terms in the middle, same radicand, right? Same index, so I can't add those. I have a negative one of them and a positive one of them, so they're going to cancel. So that product is just x squared minus 13. Okay, and finally, I have 7 square roots of 7 minus 2 cubed roots of 7, plus the square root 28. So it looks on the right at the outset like there's nothing to do, but square root of 28 is going to simplify for us. All right, that's a square root 4 times a square root 7. Square root 4 is 2 times the square root of 7. So now I have 7 square roots of 7 minus 2 cube root of 7 plus 2 square root of 7. So two of those terms can combine, right? The two that are square roots of 7. The cube root of 7 is the odd one out, right? It has a different index, so it cannot add or subtract with the other two terms. It has to have the same radicand, same index when you're adding. Okay, so I'll just add those two together. So 9 times the square root of 7 minus 2 times the cubed root of 7. Nothing else to be done on that one.